Okay, so what is Molecule? Molecule is the missing testing frameworks for Ansible playbooks and roles. And mainly, I am the current maintainer of the framework. It wasn't created by me, but about 1.5 years ago, I discovered it, and it was like a godsend solution for our team. I'm part of the OpenStack 000 team, so mainly we deploy hundreds of OpenStack clouds per day as part of the CI. And most of our code is now Ansible, and we needed to test it. And historically, we test it by doing full integrations. But doing full integrations means that it takes a lot of time, at least 2 to 3 hours for the simple ones. And we needed a way to do more, something at a lower level, like a functional testing, like testing single roles in isolation, single playbooks in isolation. Because if we touch only one piece of code, we wanted to test it with different scenarios, but without the big picture, because we wanted to get results like in few minutes, not in hours. So I will try to explain a little bit about how Molecule works. Okay, let me see. Okay. So first, probably I already covered this. Why we need to test code? Because code gets rotten, and even a minor change can have undesired side effects much later. And also, doing manual testing doesn't pay well. Good jobs are when you put computers to do the boring stuff for you. So before going into the tool itself, I will try to explain a few terms that are used a lot. What is a driver or provider? Mainly, it's a backend that is used to provide the hosts that are used for testing. Because Molecule itself does the provisioning and destroying of the test resources, because you do not want to run stuff on your local host, right? You have stuff that may wipe machines, install new services, reconfigure them, and so on. You want to have them in isolation. The scenario basically is a test. And if you are coming from a development background, it's like a test in PyTest. A scenario is made out of various commands that are run by Molecule. These commands, a group of commands make a sequence. And you can just invoke sequences instead of having to run like 2, 3, 5, even 10 steps one after another. A verifier is the step that is used to validate that what you executed produced the desired effects. So you can use Molecule to test roles, playbooks, or anything else, because it does run Ansible in the end. So effectively, what it executes Ansible, which means that you can run a shell task that does anything else that you may want. One thing that you should be aware of, that by default, the tool itself was created as a command line tool for development purposes, which means that it does not orchestrate by itself execution of multiple scenarios. But there are other extensions like PyTest Molecule that does this for you. So you can, mainly PyTest Molecule, it's a plugin for PyTest that makes PyTest believe that each molecule scenario from inside your code repository, it's a PyTest. So if you are already using PyTest, you can just plug it in and test the Ansible code with it. And also, it doesn't make coffee. So to install molecule, you just use pip. It's the easiest way. There are other possible ways, like running it from a published Docker container. By default, it comes with some plugins. In the example that you can see here, I'm also installing the optional Azure plugin and the Docker one. The Docker one is part of the core. So this is why you see as it's a pip Python extras Docker, because if you just do a pip install molecule, it will not install the Docker dependencies for it. And if you want to see what drivers you have installed, you just run molecule drivers, and it will list all the drivers that are installed. As you can see in the example below, you have Azure because you install it as an optional, and the other ones are always installed because they are currently part of the core: Delegated, Docker, and Podman. The command line is quite easy to use. You with minus help, you can get some useful information. And as you can see, you have simple commands like check, cleanup, converge, create dependency. I will explain later what they do. So about molecule drivers, these are probably the most important part, because this is what you use in order to test your roles and your playbooks. There is one special driver which is called delegated. Delegated means that I already have an inventory and you are going to use this inventory. So molecule itself will not provision anything for you, will trust the stuff that you have. This is common, for example, if you use continuous integration, where you allocate the nodes before the job starts. For example, we use Zool, and Zool creates the testing nodes for us on OpenStack. And in this case, we may use the delegated in order to, because it's externalized, let's say, the allocation. The most common driver with molecule is the Docker one. It's the most popular one because it's the easiest one and to use on most platforms. You can use on macOS, Linux, and so on. And it does give you the level of isolation that you want in order not to mess with your machine, right? Also, you can use the Podman driver, which is almost identical with the Docker one. So you can use Podman. Also, there are the cloud plugins like Azure, AWS, Google Cloud, OpenStack, Vagrant, LXD, Libvirt, which is not fully ready yet, but there is work on it. And it's very easy to switch from one to another. It's like just changing the YAML file, 2 lines in the YAML file, to switch from one driver to another. But you need to keep in mind that the driver is used by the create and destroy part, because create is allocating, is creating the inventory, and destroy is deallocating it. So yes, I think I already explained that you should use containers when you can use them. If your playbook is performing tasks that can run inside the container, you should use a container. But if you start to use stuff like systemd, you may start getting into troubles, right? If you, for example, if you have a playbook or a role that is installing Docker, probably you do not want to use a container to test that you are installing Docker. You want to use a real VM, and in this case, you use one of the other drivers. But if you deploy just a simple service or install some stuff, use containers because they have the lowest footprint. molecule verifiers. Molecule comes with 3 verifiers. The default one is now Ansible. It used to be Test Infra, which is a PyTest plugin for validating that different changes were made on a computer. It's a very useful one, but I do not recommend it if your team is not used to Python or Test Infra itself, because it's, let's say, it's more powerful than using Ansible. You can do much more innovative stuff or checks, but it's harder. If your team is more used to Ansible, it's easier to use Ansible to test Ansible, right? Because you can run few tasks to validate that the service is still running, right? After you run your code and stuff like this, or that a file was created or a file was removed and stuff like this. Ghost is another plugin, which I cannot tell too much about it. So what are molecule commands? So when you are inside, let's say you are inside the role and you want to test stuff, you can just do molecule test, and by default it will run the entire test sequence for that role. If you go to another role, you can run the same in another role, and it will run the default scenario for that role. But for example, sometimes you don't want to run the entire test sequence, and you want to run only create or converge again because you discovered that you made a mistake in the testing playbook. And you can just run converge, and it will run just converge again. So you don't need to recreate the machine, do the check-in and so on. So it's very easy to for development. In CI, obviously, that you just run test because you want to have the full testing. And to get an idea about what test does in a more, let's say, in the most complex scenario, it has about 10 steps, which these are the default ones, but you can customize them if you want. So you can remove some of them, and most of them are optional. It means that if you do not have a playbook with this name, molecule will just skip it. Dependency, for example, is installing dependencies like other roles from Galaxy. For example, linting is running the linters. Cleanup is doing some extra preparation for a machine, and destroy. As you can see, it's like just to be sure that if you run test twice and the first time it failed during converge, you start from the same machine when you run test again. So mainly you want to destroy if a machine already existed and recreate it, right? Because otherwise you may have different results when you run the second time. Converge is the most important part on it, because this is where you run effectively the tested code. Idempotest is running the same again and raising errors if you have changed task. Mainly is testing the idempotence of your role or playbook, because as you probably know, if you run it twice, it shouldn't change anything because the system should be already at the desired state. You already obviously, in some cases, this doesn't make sense, which means that it's an optional step. Verify it's a playbook where you can put extra tests that are validating that you did end up with the desired system state. Clean up and destroy, I already mentioned. So at any point in time, you can check the current state of your inventory. Doing a molecule list will list a list of instances, because molecule itself takes care of managing the testing inventory for you. And you can see what driver the instance is using, what provisioner, what is the scenario, if it was created or not. For example, if I run created, molecule create, when create, it will create, and the result will be that it's created. Converged means Did I run converge on it or not yet? So after creation, obviously that converge will be false. But after I run converge, this will become true. This is quite important when you do stuff like idempotent testing and so on. By default, running molecule tests will destroy the machines at the end. But if you want to look inside and so on, you may disable these functionalities. This is in order to, you can even define, if you want, an environment variable to disable these functionalities. This is a good protection for not having a lot of leftovers from your testing, like stone machine that runs. Because if you use a cloud, you'll end up having to pay for a machine that you forget to stop. I will show you here the default layout of a molecule scenario inside the role. Probably you already see that you have the tasks, variables. Most of this is a normal role. The only thing that is new here is that you see a molecule folder. Molecule folder is like a test folder where you put the tests. There is a subdirectory here, which is in this example called default. This is a default scenario. This is when you do not specify a scenario name from the command line with molecule, it will use the default one. But you can create as many as you want, and you can run them because you can have multiple testing scenarios for your roles. And inside you have mainly, most of these are Ansible playbooks, which are run for respective steps. The only one that is not a playbook is molecule YAML. This is the definition of the scenario, the configuration, and you'll see an example later. But keep in mind the only thing that is molecule specific in this is the molecule folder. The other stuff is just a role. So about molecule config, this is a new feature that was introduced recently, I think in the last 2 months, which allows you to avoid repeating yourself in your molecule YAML file. So you can create a config file which is inherited by the molecule YAML file. Maybe it's not very important now to go into details about it, but just keep in mind that if you end up seeing a lot of boilerplate copied from one molecule YAML file to another, there is a solution for allowing you to avoiding it, avoiding the repetition. This is a molecule YAML file and an example. Maybe you just have to specify the driver that is going to be used and the commands that you want to run. More stuff, all the other stuff are optional. Okay. Okay, I think that's all for the moment. I don't know what, let me see what questions do I have here. If molecule can be used for network infrastructure, yes, you can use it. In fact, you can even use molecule to provision your own stuff if you want. If there is a separate local driver for molecule, I'm not sure about this, but I think this is most related to delegated. So you can see delegated at something like this. Okay. Freenode. And for molecule itself, there is an Ansible molecule channel. Now I realize that I didn't update this. There is an Ansible molecule for molecule. Obviously, if you ask stuff about molecule on Ansible Galaxy, you'll get answers about it. No, And probably I will ping you. Yes, this is a mistake here because it should be Ansible dash molecule. It's quite an active channel. I think that earlier this year, molecule itself was split into plugins. So now, based on what provider you are using, you may have to go to different code repository if you have bugs. It used to be monolithical with 11 providers, and it was a nightmare to make any change because it was impossible to test with 11 clouds. And this is why we split it into plugins. Most of them are out. Only Docker and Podman are kept in for convenience. The plan is to move them also out in order to make it easier to develop the core on it. And I don't know if anyone has other questions. I'll be more than happy to answer. I know that I didn't put too many details, and I know that Gerling I had a much better presentation about molecule and so on than me. But